coding. Most applications, even from the smallest and simplest right up to the biggest and most complex, have some form of data structures in them. So because they're used everywhere, being confident using data structures will actually make you a better developer. And knowing how to choose the right one for a certain situation can make a big difference in the performance of your code, so it can make your apps run faster. I'm going to show you what to look for when you're choosing a data structure, and I'll introduce you to some of the most common and useful ones in Java. There's also some exercises along the way, so you'll get some hands-on experience of using them yourself. I'm Bethan Palmer, I'm a member of the Java Champions, and I've been working as a Java developer for the last 5 years. So if you're ready to improve your Java coding skills, then join me in my LinkedIn Learning course on data structures in Java. Before you get started with this course, there are a few things you should know. You should already be familiar with the basics of writing code in Java. So if you're completely new to Java, I'd suggest watching the course Learning Java before starting this one. If you're comfortable with the basics of writing Java code, it's time to open your favourite IDE. I'll be working in IntelliJ, which has a free community edition you can download from jetbrains.com/idea/download, but you can use whichever IDE you're most comfortable with. The examples and exercise files for this course are stored on GitHub. To download them, you'll need to have Git installed on your computer. So if you don't, you can go to git-scm.com/downloads, and there are options there to download Git for Mac or for Windows. So there's a branch for every video where we work on code. All of my examples start with an empty class, so the code in the branches shows the end state of the code I'm demonstrating. You can view a list of all the branches right here in GitHub from the branch dropdown. So if I click up here where it says main, I'll actually get a dropdown which shows every branch available in this course. So for example, if I wanted to see the branch 0202, I could click on it here, and the page will update and show all the code for that video. I'm going to show you how to download the code using the command line. Your IDE might have tools to do this visually, which might be easier for you, and feel free to use those if you want to. But if you do it from the command line, you can then open the code in any IDE, and it will give you some useful practice with the Git commands too. So the first step is to copy the link for the repository. So I'm going to click on this green button here where it says code, and if I click on these two little squares, it will copy the link for me. Next, I need to go to the command line. So I'm on a Mac, so I'm going to go to my terminal, or if you're on a Windows computer, if you search for commands prompt, that will open up your command prompt there as well. Now, the first thing I need to do in here is I need to go to the directory where I want to save the code. The command to change directory in the command prompt is cd, so I'm going to type cd, and I've got a folder called data structures in here. And a little tip, if you press tab in here, it will autocomplete the name of your directory. So I'm going to cd into data structures. And you can save this anywhere you like on your computer. I've just created a folder called data structures where I'm going to save the code, but you can save it absolutely anywhere. Now I need to download the code, and the command for that is called git clone. So I'm going to type git clone, and then I can just paste the URL I copied just now in the GitHub window. So I press enter, and that will download the code into my folder. The next step is to open the code in your IDE. I'm going to be using IntelliJ, so I'm going to open up IntelliJ, and I click on this button here that says open. Then I just need to go to the folder where I saved the code. So I saved it in a folder called data structures, and in here it will be called Java data structures 3001429, and I just click open. So by default, the code will start off on the main branch. As I mentioned earlier, I've created branches for each video in the course where we modify code. If you'd like to follow along in IntelliJ, you can use the branches pop-up menu in the lower right-hand corner. So down here, there's a little branch symbol and it says main. So if I click on this, it will show a list of all the possible branches I can use. So let's say I want to go to 0202. So I just click on here, and then it will come up with a menu with checkout at the top, and I just click on checkout. Now you might see a little window down in the bottom right that says Maven build scripts found. And if you see that, click on load Maven project. Then you might get this second pop-up, which is asking you if you want to trust the Maven project. Feel free to click on Trust Project. So now I'm on the branch 0202, and you can find the code in this source menu, in main Java, and then there's a class here called Array Examples. So that's how you change branches inside IntelliJ IDE. I'm going to show you how to do it from the command line now as well, in case you're using a different IDE or just want to get some practice using the command line. So I'm going to go back to my terminal, and the first thing I need to do here is I need to go into the directory where my code is saved. So it's saved inside a folder called Java Data Structures 30014229. And again, I'm pressing tab to autocomplete and then enter. So now I'm inside that directory. The next thing I want to do is check out the branch I want. So let's say I want to check out 0203. To do that, the command is git checkout, and then the name of the branch, so 02_03. And then I press enter, and it's switched to that new branch for me. So if I go back to IntelliJ now, I can see everything's updated. The branch has changed to 0203. I can see down here in the bottom. And the code for this branch has loaded inside IntelliJ. So what actually is a data structure? In any application that you write, it doesn't matter what programming language you're using, there will be data in it. And most likely, you'll want to group that data together in some way. Data structures are basically where you store the data together. A simple list is a really common example of a data structure. Say, for example, you have a to-do list application where people can add items to the to-do list. You're going to need somewhere to store the to-do items so you can keep track of them in your app, and somewhere where you can retrieve them from later. What you need is a data structure. In this scenario, the to-do items are the data, and the list you put them in is the data structure. So you can think of data structures as a group of things, like a group of to-do items, but as well as being a place to put things, they also give you a way to access the data inside them. In the to-do list, we want to be able to access the to-do items, and you'll also want to be able to add items and delete items from the list. You might also want to iterate over the items and apply some changes to them. Data structures also tell you how the items relate to each other. For example, does it matter what order the things are in? Or can they be in any random order? Can you have duplicated items in the data structure? Or do they all have to be unique and different? The answers to these questions will vary for different use cases, and the data structure you choose will be determined by your answers to those questions. The type of data you put in a data structure could be pretty much anything. They could be numbers or strings or booleans or bytes, or they could be instances of your own Java classes. Say you have a to-do item Java class, you could create a data structure and put to-do item objects in there. You could even have a data structure made up of other data structures, for example, a list of lists. So say you have a list of food, within that you could have a list of fruit and a list of vegetables. So data structures allow you to group data together, they give you a way to access and modify the data, and they define the relationships between the data. Now, there are loads of different kinds of data structures. In fact, there are probably more than you'll ever use in your whole career. So how do you decide which one to use? The answer depends on your use case. There are a few things to consider when you're deciding which one to go for. The first thing to think about is, do you know in advance how many items are going to be in the data structure? There might only ever be 10 things in there, or you might have no idea how many items are going to end up inside this thing. Another thing to think about is whether you want to allow duplicates. Sometimes you might not care if your data structure contains several of the same thing, but at other times you might want to enforce that no duplicates are allowed, and everything in it has to be unique. Next up is the order of elements. Is it important that the data stays in a specific order? For example, imagine a real-life queue of people outside a store. The first person to join is the first person to leave the queue. So in this case, the order needs to stay fixed. But at other times, it might not matter what order the elements are in. Another important thing to think about is the performance of the data structure you choose. Some are quicker if you want to insert and delete elements, but others are quicker at retrieving elements. So it's a good idea to have a think about what you're going to be doing with the data. Are you going to be changing and updating it a lot? Or is it going to stay the same the whole time and you're just going to be finding and accessing elements in it? The time differences might not be noticeable when you start writing a new app, but on bigger applications, or as new apps scale up, these things can actually have a huge impact on performance. One more thing to think about is memory. Some data structures take up more memory than others, which can also affect performance. This may seem like a lot to think about for something as simple as choosing a data structure, but the more you use them, the easier it gets. And there's never a perfect data structure, so there will always be some trade-offs. One of the simplest data structures in Java, and other languages too, is the array. Arrays are objects that contain a fixed number of elements of the same type. So when you create an array, you have to say upfront how many elements are going to be in it. If you change your mind later and decide you want to add some extra elements, you can't just make it bigger. You'd have to create a whole new array. Arrays can contain pretty much any type of value, from primitive types like int and double, to object types like string or our own custom types. Every element in the array has to be the same type. So, for example, you couldn't have an array where the first element is an int and the second element is a string. That wouldn't be allowed. Arrays are indexed, and they start at 0. So the index of the first element in the array is 0, and the index of the last element in the array is the length of the array minus 1. So if an array has 4 elements in it, the first one is at index 0, and the last one is at index 3. A really common bug with arrays is trying to access an element that's out of bounds. For example, trying to access index 4 in an array of 4 elements will cause an array index out of bounds exception, because the last index is actually 3. In Java, there's a class called the arrays class, which provides some utility methods that can be performed on arrays. This class can be used to do things like turn the array into a human-readable string with a toString method, or turning a list into an array, and also for searching and sorting arrays with the sort and binary search methods. Arrays are best learned from seeing some examples, so let's have a look at some code. So let's see how we'd go about creating and using arrays in Java. So I've got a class here called arrayExamples with a main method in it, and I'm just going to stick all my code in this main method. So to create an array, the first thing I need to do is I need to put the type of element that's going to be in it. So to create an array of strings, for example, I would put the word string, followed by a pair of square brackets, and then the name of my array. So I'm going to call this one weekdays. And then after the equal sign, I put new string, and then another pair of square brackets, and a semicolon. And inside these square brackets, I need to put how many elements are going to be inside the array. And this won't change, so it will be the same for the whole lifetime of the array. So there are 7 weekdays, so I'm going to put the number 7. I'm going to print this out now and see what it gives me. So if I do system.out.println, I'm using an IntelliJ shortcut there, so if you do SOUT and press tab, it will complete that automatically for you. And then I'm going to pass in the name of the array, which is weekdays. And I'm going to run this now and see what happens. So to run it, I can click on this green arrow here and do run arrayExamples.main. And I can see it prints out this ljava.lang.string and some hash code, which isn't particularly useful. So instead of passing in weekdays, I'm going to do arrays.toString and then pass in the name of the array, so weekdays. And make sure that you have the import statement at the top. So IntelliJ added it automatically, but just make sure you've got the import there for the arrays.toString method. So let's run this again and see what I get now, and it should give me a more human-readable version. So now I've got an array with 7 nulls in. What's happening here is when you first create an array, if you don't say what any of the values are going to be, Java will just use the default value for that type. So the default value for a string is null. So for ints it would be 0, and for booleans it would be false, and things like that. So now let's try setting some of the values. I want to set the first one to Monday, so to do that I can do weekdays, and then in a pair of square brackets I put the index of the element I want to change. So to change the first value I would put the number 0. And then after the equals sign I'm going to put the string Monday. Now I'm going to copy and paste the system.out.println and put this underneath here and run it again. And now I can see that I've got the first value as Monday and all the others are still null. So I could go through and set all the values like this. So I could do weekdays 1 equals Tuesday, weekdays 2 equals Wednesday, and so on. But another way to set arrays is when you create them, instead of saying how many values are going to be in it, you can say straight away what all the values are. So let's do that with the weekdays variable. I'm going to put weekdays, and I'm going to replace this array and create a whole new one. So I'm going to do new string and a pair of square brackets. And then instead of putting a number in the square brackets, I'm going to put a pair of curly braces. And then inside the curly braces, I put the values that I want to be in the array. So I'm going to put mon for Monday, tu for Tuesday, word for Wednesday, and I'll stop there because I'm lazy and I can't be bothered to write all 7. So let's copy the system.out.println again and put that underneath and rerun it. And now I've got an array with 3 values in: Monday, Tuesday, Wednesday. So there are 2 different ways that you can create arrays and instantiate the values inside them. The next thing we might want to do is we might want to iterate over the array. So to do that, one thing I can do is use a for each loop. So I could do for string day in weekdays. So that's going to go through each string in the weekdays array. And let's say I want to print out weekday and then the weekday. So I'm going to do system.out.println and pass in the string weekday and then add the day to that string. So I'm going to run this again. Another way you can run the program in IntelliJ is at the top there's a green arrow that will run the class for you. And now I can see I've got weekday Mon, weekday Tues, weekday Wednesday. So that for each loop lets me iterate over each value in the array and access it. But I can't actually alter any of the elements when I do it like this. I need an index to keep track of them. So another way to iterate over them is using a for loop with an index. So I can do for and then int I equals 0 for the index, and then I is smaller than weekdays.length. I don't want it to ever be equal to weekdays.length because that would give me an out of bounds exception because the index starts at 0. And then I++. And let's say I want to make every value in the array all in capital letters. So to get each element, I'm going to do weekdays and then pass in I for the index. And I can do equals weekdays I, and I'm going to call the toUpperCase method. So this should make every element in the array all in capitals. I'm going to copy and paste this system.out.println again and put this underneath. So let's see what happens when I run it now. And now I can see that every element in the array is all to uppercase. So that's how you'd iterate over the array if you wanted to make some changes to the elements inside it. So let's have a look at our first exercise. In this one, I've got a class called ArrayExercise, and this has got 2 methods in it, one called ArrayToUpperCase and one called IncrementArray. I've already filled out the ArrayToUpperCase method just to use as an example to show you how it works. So this is a method called ArrayToUpperCase that takes an array of strings called input, and it loops over this array and calls the toUpperCase method on each one, so it's making everything capital letters. Very much like the example I showed in the previous video. Now, there's also a class in here called ArrayExerciseTest. Now, there's also this class called ArrayExerciseTest, which has some unit tests in it. Don't worry if you're not too familiar with unit tests or JUnit or anything like that. I'm going to talk you through it and show you how it all works. So there's 2 tests. The first one is called testArrayToUpperCase and another one called testIncrementArray. So let's start off with looking at this example one, testArrayToUpperCase. In here, I've got an array of strings called input, and I'm creating a new array with 3 things in it: cat, dog, and fish, all in lowercase. Then I'm doing ArrayExercise, ArrayToUpperCase input, so I'm calling the method that I filled out already in the other class. Next, there's this method called AssertArrayEquals, and this is just checking that 2 arrays are the same. So after I've called the ArrayToUpperCase method, I'm expecting to get back an array of strings with cat, dog, and fish, all in capital letters. So this is just testing that my input is now an array with cat, dog, fish, all in capitals. So let's run this test and see what happens. I can run it by clicking on this little green arrow on the left and clicking run. And I can see it says at the top, test passed, and there's a green tick, lots of green ticks here. So it's fairly clear this test has passed. Now let's look at the exercise test. So this one is called testIncrementArray. In this one, I've got an array of ints, and it's an array with 1, 2, 3, 4, and 5 in. And then I'm doing ArrayExercise, IncrementArray, and passing in the input. So what this method should do is it should add 1 to each of the numbers in the array. So what we're expecting to get back from this one is 2, 3, 4, 5, and 6, because I've added 1 to each of the numbers in there. But at the moment, there's no code in this IncrementArray method, which I showed you earlier. It's just empty. So when this gets called, nothing's going to happen. so I'm expecting this test to fail when I run it. So let's run it and see what happens. And as expected, you can see it says tests failed 1, and there's lots of red writing showing you that the test has failed. And if I look at the error message, it says array contents differ at index 0, expected 2, but actually it was 1. And that's because nothing's actually changed with that array. So in this exercise, what you need to do is go to the array exercise class and add some code in this method to try and make that test pass. So when you've written some code to iterate over the array and add 1 to each of the numbers in it, if you rerun the test afterwards, you should see it go green and pass. I'm also just going to quickly show you how to run these tests from the terminal, just in case you're not using IntelliJ and you don't want to use your IDE's built-in features. So on my Mac, I'm going to go to my terminal, or if you're on a Windows machine, go to Command Prompt. And first of all, you just need to make sure that you're in the same directory as where your code is saved. So I'm in Java Data Structures 3001429. Now to run the tests from the command line, on a Mac, all you need to do is do /mvnw space and then test, and then hit enter, and that will run the tests. And I can see straight away from all the red writing and the word error everywhere that one of the tests has failed. So if you're on a Windows machine, it's very similar. You just open up your command prompt, and instead of doing ./mvnw, you do ./mvnw.bat space test. And if you run that, it will run the tests in exactly the same way. So I'm expecting this will take you about 10 minutes to do, but don't worry if it takes you longer than that. Good luck and have fun. Now let's have a look at the solution to the exercise. So in this increment array method, I've added a for loop. So I'm saying my index I is equal to 0, and it should continue looping while I is smaller than the size of the input array. And then I'm going to say it should add I to 1 each time. Then in the array, I'm getting the value at index I, and I'm assigning this to that same value, input at index I plus 1. Now I can see if it's worked by running my test. So I'm going to go back to the array exercise test class, and I'm going to rerun it by clicking on this green arrow again and choosing run. And now I can see that it's passed, so that means my code is working as expected. Well done if you managed to make your test pass too. Most data structures in Java implement the collection interface. So if you've ever even created a simple list, then you've probably used the classes that implement collection. There are several other interfaces that sit underneath this, so things like list, queue, and set all extend the collection interface. And since Java 21, there's also a new one called sequenced collection, and this provides a more uniform way of getting the first and last elements in the collection. And then there are all the concrete classes that sit underneath these that implement these interfaces. So for example, ArrayList implements the list interface, which extends the collection interface. And Priority Queue implements queue, and HashSet implements set. These are just a couple of examples. There are actually lots more interfaces that extend collection, and lots more classes that implement those interfaces. You might hear this structure referred to as the collections framework. It's the backbone of most data structures in Java, so it gets talked about quite a lot. The fact that these classes are all part of the same group of classes that stem from collection at the top is pretty handy. It means that there's a consistent API. There are only a set number of methods to remember when using all of these different classes. For example, add, remove, clear, contains, is empty, size, and so on. These are all the same in all the different concrete implementations. So once you're used to using those methods, you can use them on loads of different concrete classes. And above the collection interface, there's actually another interface called iterable. This is the very top of the collections framework. This means that any of the classes in the framework can be iterated over using an iterator object if you want to. There are lots of differences between collections and arrays in Java. For example, collections can change in size, and you don't have to specify when you create them how many items will be in it. So it can grow bigger over time or become smaller as elements are removed. They also can't hold primitive types. The first data structure from the collections framework I'm going to look at is the linked list. This is an interesting one because it's doubly linked, which means that each element in the list has a reference to the next element and the previous element. So let's see what it looks like by creating a simple shopping list using a linked list. To do that, I do linked list, and then in a pair of diamond brackets, I need to put the type of element that's going to be in the list. So if I want strings to be in my linked list, I put string. And then I can give it a name. So I'm going to name this one shopping list. And I can do equals new linked list. So now I've got a new empty linked list. And the next thing is to add some items to it. To do that, there's a method called add. So I can do shopping list.add. And then I'm going to pass in the string apple. Then I'm going to add a few more shopping items. So I'm going to do shopping list.add and pass in banana. And then shopping list.add, and I'm going to pass in pear. So let's print this out and see what it looks like at the moment. So I'm going to do system.out.println and pass in shopping list. And I'm going to run this now and see what I get. So in the output down here, I can see I've got a list with 3 items in it: apple, banana, and pear. And notice that they're in the same order that I added them in the list. So linked lists keep items in the same order. Now let's say I wanted to add an item at second place in the list, so not at the end, but after apple and before banana. I can do that with linked lists by using the add method again, so I can do shopping list.add, and then I'm going to put the index where I want the element to go. Linked lists start at index 0, so in this example, apple is at index 0 and banana is at index 1, and I want my new item to be at index 1, so I'm going to pass in 1, and then the name of the item, so I'm going to add a mango. Now I'm going to print this out again. So I'm going to do system.out.println and pass in shopping list again and rerun it. And now I can see I've got a mango in second place. So it's apple, mango, banana, and pear now. Linked lists are quite quick at adding elements like I've just done there. They're quicker than array lists for adding elements and removing them. Array lists look really similar to linked lists, but behind the scenes, array lists are actually arrays that get resized. Whereas on the other hand, a linked list is a set of elements where each is linked to the other one. So in this example, the banana has a reference to the pear, which comes next, and it has a reference to the mango, which comes before it. And that's changed since I added the mango. So before, banana had a reference to apple as coming before it, so I had to update that reference when I inserted mango. This means that linked lists are a bit slower at randomly accessing elements, because it has to go through and see what one comes next until it gets to the one it wants. So array lists are quicker for randomly accessing elements, but linked lists are quicker for adding and deleting elements from the list. Linked list also comes with some handy methods called add first, add last, remove first, and remove last to add or remove elements to the front or the back of the list. So I'm going to give that a go with the remove first method. So I'm going to do shopping list.remove first. And then I'm going to print out the list again to see what's in it now. So I'm going to do system.out.println shopping list. And when I rerun it, I can see that it's removed apple from the front of the list. So now it's just mango, banana, and pear. One last thing to note about linked lists is they aren't synchronized, which is a good thing in terms of performance and memory and things like that. But it does mean that it's not thread safe. So if you've got multiple threads trying to modify the list at the same time, they might overwrite each other's changes. Luckily, it's really easy to make linked lists synchronized, and I'll show you how to do that now. So I'm going to create a new list. So I'm going to do list string in diamond brackets again, and I'm going to call this one synchronized shopping list. And I just need to make sure that I've imported the list class. And then I can do equals, and on the right side, I'm going to do collections.synchronized list. And then I can pass in shopping list. So this will make a copy of the shopping list, but put it in a list that is synchronized. So if I print this out and I do system.out.println synchronized shopping list and rerun the program, I can see my new list, synchronized shopping list, is exactly the same as the old one. So it's made a copy of it, but now it's thread safe, and I can just continue using it like a normal linked list. The next data structure we're going to look at is the stack. Stacks are a data structure where the first element you add to it is the last one you take out. So you can think of it like a real life stack of plates. When you stack plates on top of each other, when you want to pick one up, you would take it from the top of the pile, and the first one you put down stays at the bottom. There's actually a couple of different ways to create a stack in Java, and neither of them are perfect. There is a stack class, but it has a few limitations. For example, it lets us remove elements from anywhere in the stack. If you imagine a real-life stack of plates, this isn't very stack-like behavior. So it's generally recommended to use the deck interface instead. So I'm going to demonstrate using a deck here, but it is worth being aware of the stack class because you might come across it in older code. So to create my stack, I'm first going to type deck, which is spelled D-E-Q-U-E. And then in a pair of diamond brackets, I put the type that's going to be in the deck. So I'm going to put string, and I'm going to call it stack. And then after the equal sign, I'm going to put new. And then I can't put deck because deck is an interface, so I need to put a concrete type. And the name of the concrete type I'm going to be using is called array deck. So now I want to add some things to my stack. The method for adding things to a stack is called push. So I'm going to do stack.push, and I'm going to pass in the string first request. So when you're using a stack, you might have a load of requests where you want to make sure that the last one you add to the stack is the first one that gets processed. And then I'm going to do stack.push and put second request. And one more, I'm going to do stack.push and pass in third request. So now let's print it out and see what it looks like. So I'm going to do system.out.println and pass in stack. So if I run it now, I can see I've got 3 objects, and the last one I added, third request, is first, and then second request, and then first request. So it's in reverse order to the order that I added them in. If I did this using the stack class, it would actually print out the elements in the opposite order, so the first request would be on top, and the third request would be last. Again, this isn't really how stacks should behave, so it's another reason to use the deck interface instead. Now, the method to get the top element off the stack is called peek. So I'm going to do system.out.println and pass in stack.peek to get the first element. And when I rerun it now, I get back third request because that's the item on the top of the stack. So if I want to remove the first element from the top of the stack, I can use a method called pop. So I'm going to do stack.pop. And then another system.out.println, and I'm going to pass in stack again to see what the stack looks like now. So if I run this again, I can see that third request has been removed from the top of the stack. So now I've just got second request, first request. You can also use a method called poll, which is very similar and pretty much does the same thing. So if I do stack.poll, and then another system.out.println and pass in stack, when I rerun it, it's removed the top element again. So now I'm just down to one thing, first request. The only difference between poll and pop is when you use pop on an empty queue, it will throw a no such element exception. Whereas if you do that with poll, it will return null. One last thing to bear in mind is that ArrayDeck is not thread safe. This means that it's much faster than the stack class, which is synchronized. But it is something to be aware of if you use it in a multi-threaded context. Now let's look at the queue data structure. In a queue data structure, the first thing you add is the first thing you take out. Think of it like a real queue of people waiting outside a store. The first person that joins the queue is the first person that gets served. So like with stacks, there's actually multiple ways to implement a queue in Java. In fact, there's loads of ways. But the good news is that when you know how to do it with one concrete class, it's very similar for all of them. Because they all implement the queue interface in Java, the methods they have are largely the same. So when you choose which one to use, you don't have to worry about learning a whole new set of methods. You can just worry about what specific features you want your queue to have. One way to make a queue is with an ArrayDeck, which is the same class I used to create a stack in the previous video. So I'm going to demo using this ArrayDeck class again. To create my queue, the first thing I'm going to do is type queue. And then in a pair of square brackets, the type of elements in the queue, so I'm going to put string. And I'm going to call this queue. And I just need to make sure that I've imported the queue class. It is important to use queue on the left side of the assignment, because that makes it easier to change which concrete type you use later on if you want to. It also makes it less likely people will accidentally use methods that aren't queue related, because they might then inadvertently change the behavior to not be queue-like. So on the right-hand side, I'm going to put the concrete type I'm going to use ArrayDeck, so I'm going to put new ArrayDeck. The method to add items to a queue is called offer. So I'm going to add 3 people to the queue, person 1, person 2, and person 3. And to do that, I do queue.offer, and then person 1, and then queue.offer again, and pass in person 2, and then queue.offer and pass in person 3. So now I've got 3 people in my queue. Let's print that out and see what it looks like. So I'm going to do system.out.println and pass in queue. And when I run this, I can see I've got person 1, person 2, and person 3. So the first thing I added is at the front of the queue. And then person 2, and then person 3, the last one I added, is the last thing in the queue. Now I want to see the item that's first in the queue. So similar to the stack example, I'm going to use the peek method again. So I'm going to do system.out.println queue.peek and rerun it. And this tells me that the first thing in the queue is person 1. Now let's say I want to remove the first item. To do that, I can do queue.poll. And I'm going to print it out again, so I'm going to do system.out.println and pass in queue and rerun it. And it's removed person 1 from the front, so now I've got person 2 and person 3. Unlike stack, there's no pop method, so this time I have to use poll. Now, I could actually change this ArrayDeck class to some other concrete implementation. For example, I could change it to linked list. So let's change it to linked list. And I don't actually have to make any changes at this point. If I run it again, I can see the output's still the same. So I've got a list with person 1, person 2, person 3. And when I do queue.peek to get the first item, it gives me person 1. And then when I do queue.poll to remove the first item, I've still got person 2 and person 3. So everything is exactly the same. And linked list is quite a common implementation to use for a queue, but in most cases the ArrayDeck has better performance. Linked list is better if you're removing the current element during iteration though. Another option I could change it to is something called priority queue. So I'm going to change linked list to priority queue. And let's run it again and see what happens. So this one is slightly different. So I've got person 1, person 2, and person 3. And then when I get the first element, again is person 1. But when I remove that element, what I've got left is person 3 and person 2. So person 2 and person 3 have swapped places. What's happening here is with a priority queue, the retrieval order is the natural order. So for strings, it's done alphabetically. So person 1 is still first because it's first alphabetically, but person 3 comes before person 2 alphabetically. So the order is actually person 1, person 3, person 2. So when I remove the first element, it removes person 1, but it leaves person 3 and then person 2 because it's done it alphabetically. If it was a queue of numbers, even if you put the numbers in a random order, the first one to be retrieved will be the lowest, and the last one will be the highest number. So that's what priority queue is for. But for this demo, I'm going to put this back to ArrayDeck because it's one of the more common implementations. Next up, we're going to look at tree sets. Tree sets are a data structure that store unique elements in a sorted order. So let's see what that actually looks like. I'm going to create a tree set. So the first thing I want to do is I'm going to type set. It's good practice to use the parent type on the left-hand side. So that means that if you change your mind about which concrete type to use later, you can just change the right-hand side and leave the left-hand side as it is. So I'm going to type set, the interface, and in diamond brackets, I'm going to put the type of element that's going to be in the set. So I'm going to create a tree set of integers, so I'm going to type integer. And I need to make sure that I've imported set as well. And I'm going to call this one tree set. Then I'm going to do equals new tree set. So on the right-hand side, I put the concrete type tree set. Now the method to add elements to a tree set is called add. So I'm going to do treeset.add1 to add the number 1 to my set. And then I'm just going to go ahead and add some more random numbers. So let's do treeset.add 300, treeset.add 47, and treeset.add, let's go 6. Now I'm going to go ahead and print this out to see what it looks like. So I'm going to do system.out.println and pass in treeset. So let's run this and see what I get. And I can see I've got 1, 6, 47, 300. So it's not put them in the order that I added the elements in, but it's put them in ascending order from lowest to highest, so 1 up to 300. One of the key features of the tree set is that it stores elements by default in ascending order, so for numbers it will store them going up with the smallest first and the largest at the end. Another feature of tree sets is that you can't store duplicate values, so let's give that a go and see what happens. So I'm going to add a new line and do treeset.add, and I'm going to try adding another 6. Then I'll do another system.out.println and pass in treeset again and run it again. And I can see I've still got 1, 6, 47, 300. So there's still only 1 6 in there, even though I tried to add another one. Now I'm going to try creating a tree set of strings and see what that looks like. So I'm going to do set, and in my diamond brackets, I'm going to put string. And I'm going to call this one word set. Then I'll do equals new tree set. I'm going to go ahead and add some animals to this one. So I'm going to do wordset.add and pass in tiger. Wordset.add and pass in giraffe. And wordset.add, and I'm going to pass in bear. Now I'm going to print it out and see what I get. So I'm going to do system.out.println and pass in wordset. And run the app again. And I can see it's put them in alphabetical order this time. So it's gone bear, giraffe, tiger, because bear comes first alphabetically and tiger comes last. I can also define a different way to order strings if I want to. So for example, I could order these ones by length instead. To do this, I'm going to put something inside the constructor for the tree set. I'm going to type comparator with a capital C, dot comparing, and I'm going to pass in a string and 2 colons and length. So this is telling it to sort the words by the length of them rather than alphabetically. So let's go ahead and run this again. And now I can see it's bear, tiger, giraffe, because bear has 4 letters, tiger has 5 letters, and giraffe has 7 letters. Now let's see what happens when I add another animal. So I'm going to do wordset.add and pass in wolf. So wolf has 4 letters in it. So I'm expecting it either to come before bear at the beginning or maybe after bear, in between bear and tiger, because bear and wolf both have 4 letters. Now let's print out the word set again. So system.out.println and pass in word set. And I can see that unexpectedly, wolf actually isn't in there at all. I've got bear, tiger, and giraffe still, but even though I've added wolf, it's not appearing. This is because wolf has 4 letters and bear also has 4 letters, and when I'm comparing strings by length, the tree set is counting that as a duplicate. So in this case, it's not including words with the same length. I can also remove elements from a tree set by using the remove method. So let's try removing giraffe. So I'm going to do wordset.remove, and I just pass in the string giraffe. And I'm going to print it out again. So I'm going to do system.out.println and pass in wordset and run the app again. And now I can see I've just got bear and tiger, so it's removed the giraffe element. Let's take a look at the second exercise. This one lets you practice each of the data structures I've looked at in this chapter. So, like the first exercise, this one has a test class with some unit tests in it, and this class is called Collections Exercise Test. And there's also a corresponding class called Collections Exercise. So each of the tests in the Collections Exercise Test class will have a corresponding method in this Collections Exercise class. So I've done the first one for you as an example, so this test should pass when you run it. I'll talk you through that now so that you have an idea of how this works. The one I've done as an example is called test add 6 to end of linked list. So in this test, I'm creating a linked list of integers called numbers, and I'm populating that linked list with the numbers 1, 2, 3, 4, and 5. So I've got a list with those numbers in. Then I'm doing collections exercise.add to end of linked list, and I'm passing in numbers, my linked list, and the number 6. So the idea of this method is it should add a number to the end of the list. In this case, I'm adding a 6 to the end of my numbers list 1, 2, 3, 4, 5. So this method, add to end of linked list, is from this collections exercise class. So I can see the method here, add to end of linked list. And all I'm doing in this method is I'm doing numbers.add. So I'm adding the number I, which I'm passing into the method, onto the end of my list. So I'm going to click on the green arrow and do run test add 6 to end of linked list. And I can see it's passed as I was hoping it would. Now, if I run the other methods in this class, these will all fail at the moment because the code hasn't been written to make them pass. So this exercise is to write that code. So the idea of this one, test add 0 to start of linked list, is to write some code to add a number to the start of a linked list in this add to start of linked list method. Once you've done that, this test should pass. So there's a method for each of the data structures we've looked at in this chapter. So there's one for linked list, there's one for stacks, there's one for queue, and there's one for tree set. I think this will take you about 20 or 30 minutes to do, but do not worry if it takes longer than that. And if you get stuck, don't worry, feel free to go back to the previous videos to refresh your memory, or I'll be going through the solutions in the next video. Let's look through the solutions for each of the tests in this challenge. So I demoed add to end of linked list in the previous video, so I'm going to skip that one and go on to add to start of linked list. So in this one, I'm just doing numbers.add first and passing in the number I. So this will add the number I to the start of the list. You could have also used the add method. So if you'd done numbers.add and then passed in the index, so 0, and then I, that would work just as well. So moving on to the next one, remove item from top of stack. So in this one, I'm passing in a stack, and in the method, I've just done stack.pop, because pop is the method to remove an item from the top of a stack. The next one is remove item from front of queue. The method to remove an item from the front of the queue is poll, so I've just done queue.poll. And the final one is add item to tree set, and I'm passing in a set of strings and a string item to add. And in the method, I'm just doing set.add and passing in item. So this will add the item into the set. So I've completed all the methods, so my test should all pass now. I'm going to go back to collections exercise test and run them all and see what happens. I can run all of them by clicking on this green arrow up here next to where it says class, and this will run every test in the class. So I'm going to do run collections exercise test. And all my tests have passed. I've got tests passed 5 of 5. Well done on completing the exercises. If you want a further challenge, you could try adding some tests of your own to the test class and then writing the code to make them pass. For example, you could add a test to sort the colours in a tree set by length, or something like that.